This presentation is entitled It Pays to Use Bayes. This is Dr. Bob Hoyt. We're going to briefly discuss Bayes' theorem and how you use it in clinical medicine. Keep in mind that Bayes' theorem is still alive and well after 261 years. This is Bayes' theorem formula, which I think creates a lot of confusion. Number one, because you have to know how to plug in the numbers, and number two, different authors use different terms for different parts of this formula. For instance, the posterior probability is also called the post-test probability. Likelihood is also named differently, so we're going to give you a more abbreviated formula that's easier to understand. And we're going to first start by applying it to diagnostic medical test. And at the very bottom is an article written that talks about how to use Bayes' theorem with COVID-19, which is very practical. So in that article, they determined that COVID was in about 5% of the people in the area. The average sensitivity of home testing is about 63% with a specificity of 99%. So if you try to calculate the positive predictive value, which is also precision, it's going to be very low if the prevalence is very low, and I'll try to demonstrate that. So low prevalence automatically means low PPV. Look at the table on the right. If you start with very few true positives, but a lot more false positives, positive predictive value is very low at 0.16. Now let's add a lot more true positives, 100, with 50 false positives, the same number, and the positive predictive value is much higher. So there is the formula for the positive predictive value. It's true positive over true positive plus false positives. So if you have a lot of false positives, by definition, you'll have low precision. As the PPV increases, though, you'll see as true positives increase, the PPV increases. So if the PPV is low based on low prevalence, it's pretty misleading. What then is the next step? The next step is to determine the likelihood ratio. And you can determine a positive likelihood ratio or a negative likelihood ratio. You'll use the positive if you're interested in a positive test. In this case, we're talking about COVID. Or negative if you're interested in a negative test. And to make it simple, a positive likelihood ratio is the true positives over the false positives. Negative likelihood ratio is the false negatives over the true negatives. So we'll end up calculating both positive and negative in this demonstration. We'll then plug the answers into a Fagan's nomogram to determine what the real positive predictive value is after taking into account both the likelihood ratio and the prevalence. So the simplified formula is the post-test probability of a diagnostic test is the pre-test probability or prevalence times the likelihood, and that's what I call the simplified Bayes theorem. This is an example again from that article. And in that article, they use either the prevalence as being low or the clinical suspicion is low. On the right, you see Fagan's nomogram. You see low, medium, and high probability. This would also be the same if it was low incidence, intermediate, and high incidence. But when you calculate the negative likelihood ratio, which is calculated again, 1 minus sensitivity over specificity, you get 0.374 for the negative likelihood ratio. So now you can plug it in to the nomogram. For instance, if you have a low probability, either clinically, like the patient has no fever, minimal symptoms, and you draw a line between that and the negative likelihood ratio, it comes down as the post-test probability is very low. So if the probability is, if the probability is high, the post-test probability of COVID is also high, even with a negative test. So this nomogram is good from the educational standpoint because you can experiment with different probabilities and prevalence and see what happens. And for all intents and purposes, the post-test probability is the positive predictive value. Now, what about the positive likelihood ratio? Once again, we'll calculate it, but this time we come up with 63. So using this nomogram with a low prevalence of 5%, the post-test probability is about 75% of having COVID with a positive test. There's one other approach. Several calculators, such as MD-Calc, allow you to just input the true positives, false positives, true negatives, and false negatives, and it really does all the rest. On the right, you can see the fact that it generated the numbers that you're interested in. So in conclusion, Bayes' theorem is very useful when you're analyzing diagnostic medical tests in the face of low prevalence. PPV and NPV are affected by prevalence, so a low PPV is expected and not very useful. Using Fagan's nomogram or a calculator program, you'll get a much more realistic post-test probability.